Alright, so today we're going to look at two-step rearrangements where we have unknowns on both sides. I say two-step loosely because you could do this in multiple steps, and the first one I will, but then I'll show you how you can kind of expedite the process. So the first one, once again, we're making x the subject, so that means want to look at where our x's are. Well, we have an x right here and an x right here. So I notice that this one is more positive, so I'm going to choose to subtract off 2x from our right side. That means at the end our x will be positive, which is nice because then we don't have to swap all the signs of everything around. Okay, so let's rewrite what this is going to become. This will be 2y plus 2x equals 8y minus 6z. So here now I can see, well, I got to get rid of this 2y on the left side now. So I'll have to minus this 2y. So then I subtract 2y from here. And notice how I'm lining up my y's. That helps me because then I can see, oh, that I just have to subtract just like I normally would. So you can ignore just the variable at that point. So this means I have 2x equals 6y minus 6z. Now I have two x's, but I just want one. So how do I get that? I have to divide by 2. So I divide that side by 2. I'll be left with x equals 3 over 2 y minus 3 over 2z, or you could write it as x equals 3 over 2 y minus z if you want to be fancy. Okay, so that was kind of, you could see that we had almost 1, 2, 3 steps, right? So I'm going to show you where we can combine step 1 and 2. We're going to combine these together for this problem. So how are we going to do that? We just have to be a little careful. So if this doesn't work for you and you think this is confusing, you can follow example 1 for everything in that stands suit. But you might just, at some point, you might want to start considering this. So first thing, I'm going to look at what I have because you might be able to combine some things or simplify. So we have 9q plus 3yq equals 3qy plus 18p plus yq. So I notice I'm going to actually combine this a little bit because that actually can be simplified, this term and this term. So that is going to be 9, actually I'll rewrite it in red, follow, 9q plus 3, and I'm going to swap this so it's more alphabetical, so 3yqy equals 4qy plus 18p. If you're wondering how I was able to combine those, remember, just because they're multiplied, that means we can switch around the lettering. We can switch in any order we want. We could write the number, the 4, or this 4 at the back if we wanted. It just wouldn't look very nice, or convention, right? So here, now we want to look at our sides. This is 3, this is 4. So that we want to subtract off this 3qy. So we subtract off 3qy. So we're moving everything to this right-hand side. So that means we have to move this to the other side, the 18p. So this is where, if you take your time, you can start to see the pattern. So whatever you, so 1, I'll just write out the directions. 1, figure out what you have to subtract. 2, subtract it from this side. 3, whatever terms are beside that, move them to the other side. Then you're going to see that we're pretty much done. Some cases we're going to be done. So let's rewrite this now as, well, we have 9q, right? 9q on our 9q minus 18p on our left. That's going to be equal to qy. That's it. So we want y just by itself, so we have to divide now both sides by q. I'm just going to rewrite this over here in purple as y equals 9 minus 18p over q. So like I said, you do not have to do that in one step of it. That kind of confuses you, but it follows the same process every time. Figure out what's going to make your a positive subject, then subtract it from both sides. So you get that positive subject beside the positive subject, then subtract that to the other side, then divide or multiply. Okay, so a lot more complicated looking problem. I'm going to run through as quick as possible. So we have, we're trying to look for z's. So here's a z, here's a z, here's a z. So in this one, it looks a lot more complicated. I'm just going to move all my z's to the right side. So minus 2z minus 5xz. So that means also I want to move this to the other side, so I'm doing the opposite to it. So I have to minus 4x y squared, and also I have to minus 2z minus 5x z. So that looks really confusing. It kind of is, but as long as you take your time, because you can do little things like this to make your life easy after. So that's going to disappear, that's going to disappear, that's going to disappear. So if you cross them out, it can save when you're trying to write them down. So let's rewrite this as 8x cubed y minus 4x y squared. It's going to be equal to 8x z minus 2z minus 5x z. Okay. So, how do I proceed from here? Well, this is actually going to be a little bit tricky. So here, one trick that we can do is actually factor out. Notice how there's one z in each of these terms. I'm going to factor out my z and just leave everything else. So 8x minus 2 minus 5x. I can kind of see that I can combine those two terms as z. So that's 3x minus 2 and equal to this 8x cubed y minus 4x y squared. So now I actually just divide by this entire bracket. And so we'd be left with z is equal to 8x cubed y minus 4x squared divided by 3x minus 2. And that's actually more than kind of a two-step problem. That's actually, that bracket was not supposed to kind of appear and have to factor out a z. So that is kind of one of the hardest problems you'll see, and we'll cover more of those in the next video.